Good morning, everyone, and welcome to this lecture. This is lecture number 3. We are dealing with magnetic effects of current. And in the previous class, we have gone through very important aspect, which is the Biot Savart law for a current carrying element. We have seen that the magnetic field due to a small current carrying element is given by this formula mu naught I dl sine theta by 4 pi r square. This is at you see the scalar formula. We also have the vector formula for this. Remember, magnetic field is a vector quantity. Magnetic field is a vector quantity and the direction of magnetic field is given by dl cross r, the cross product. Do we remember this cross product? Yes or no? You remember this cross product? We had seen how do we find out the direction of this cross product. We had seen that we can find out the direction of this cross product using the right hand thumb rule. You point your fingers in the direction, you point your thumb in the direction of current. You move your palm in the direction of the point, and the fingers will give you the direction of magnetic field. All of us remember this, yes or no? Yes or no?
Yes, sir.
Yes,
Perfect.
sir.
No doubt, sir.
No
Because
doubts.
to find out the direction of magnetic field, it is the most important aspect of this chapter. If we understand how we can find out the direction of magnetic field, that is the only confusing part in this entire chapter. If you can remember that part, well, the chapter becomes very easy. If you don't understand that part, well, then the chapter becomes very tough, because if you find out the direction of magnetic field, and even if the direction you find out is reverse or ulta, then your entire question will become wrong. So we will emphasize on that direction, and I'll give you certain examples where you can find out the direction of magnetic field on your own. So let me start with this one. For example, if I have a wire like this carrying current in this direction and the point P is here, what will be the direction of magnetic field at point P? Can anyone tell me what will be the direction of magnetic field at point P? What will be the direction of magnetic field at point P? Yes or no? Yes.
Sir, outwards.
Think again.
Inwards.
Your current is like this. Your point P is on this side. And you point your fingers will go inside. That means the direction of magnetic field would be inside. Do we understand this?
Yes, sir.
If your current is like this and the point P is here, then tell me what is the direction of magnetic field. Turn your fingers, that is what you got to do.
Sir, inwards.
Think again. Look at the direction of current.
Current. Is it what?
Draw the diagram on your paper and try to turn your fingers in that direction. Current is like this. Point P is upwards. So see your direction, where it is coming. It will be coming outwards. Do we understand this? Yes or no? Outward means it is coming towards you. Here. Now tell me the direction of magnetic field. Turn your fingers and see the direction of magnetic field. If you cannot turn your fingers in the same direction, the current is like this and the point P is downwards. If you cannot do it, so what do? You do the reverse. You take the direction of current reverse and then find out the direction. Whatever direction comes, you inverse it. So if you cannot turn your fingers in that direction, you can do the reverse one and reverse your answer. Do you understand what I'm saying? If
Yes,
you
sir.
cannot, if you cannot do, if you cannot turn your fingers, you can do the reverse case and then reverse your direction. Yes. What is the direction of current here? Inward or outward? So, you see, I'll make one more point here, point Q. Now it becomes easier for you to understand. At point Q, it is coming outward. Yes or no? At point Q, it will come outward. Yes or no? Point P is on the other side. So if you cannot turn your fingers without even turning your fingers, you can say that on the other side it will come inwards. Do you understand this? Do we understand this?
Sir, can you explain it again?
Turn your fingers and get the direction better. There is nothing that I can explain here. You have to turn your fingers in the direction, put your thumb in the direction of current. Do not look at the board. Draw it in your books. Look into your books and then do it. Don't look at the board and make anything. Draw it in your books and see whatever answer comes from your book, that is also correct. Outward is always outward, whether it is coming out from your book or it is coming out from the board. It may become difficult for you to do it from the board. Do not do it from the board. Do it from your book. The good thing about the book is if you cannot rotate your hands, you can rotate your book and see where it is coming. Doesn't matter. You have to get the right direction and it doesn't matter how you get it. Current is like this, point P is upwards. What will be the direction of magnetic field? Remember, in this direction, your thumb should go, your palm should go in this direction. P means palm. Your palm should go in this direction, and you can see in which direction your fingers are turning. It's as simple as that. So where it is turning? Current is here. Point P is upwards. The finger are pointing like this. This is going in. This is coming out. If it is coming towards you, it is out. If it is going away from you, it is in. So in this case, the magnetic field is going inside. Do we understand this? I'll give you time. You do it with your own hands and find out the field at different points. This is the next case. Turn it. Turn your hands. Current eye is like this. Your thumb should go in this direction. Your palm should go in this direction. If you cannot do it in this direction, you can rotate your books You can rotate. If it is becoming difficult to do it like this, rotate your book. You will get the right direction. Doesn't matter. Rotate your book in the direction in which you can turn your fingers. Try it. I have given you all these cases. I'll give you 5 minutes for everyone to try it on their own. Do not look at the board. If you cannot turn your fingers according to your board, please draw the diagram on your books. Rotate the books in that direction in which it is easier for you to turn your fingers. Here it will be coming out. So I've given you 1, 2, 3, 4, 5, 6. 6 different cases. I'll give you 5 minutes. Everyone should be able to get all these 5 cases correctly. Everyone should be able to get these 5 cases correctly. Everyone should be able to get these 5 cases correctly. Once you are done with this, then let me know. Everyone understands how to do this? Pink is the thumb. Blue is the palm. Pink is the thumb. Blue is the palm. Pink is the thumb. Blue is the palm. Here or here. I'll give you 5 minutes. Everyone, rotate your hands. If you cannot rotate your hands according to the board, you can do the reverse of it one way. Or if you have drawn it in the book, you can rotate the book. You can rotate the book. If on your book, the current is like this, forward, you cannot do it. Rotate the book like this and then do it. Rotate the book like this and then do it. Rotate the book like this and then turn your fingers. In one configuration, in one rotation, one particular rotation, it will be easier for you to rotate your hands and your fingers. I'll give you 5 minutes. At the same time here, please note one more point. Magnetic field is the cross product of dl and r. So you can note here magnetic field will be perpendicular to both your dl vector and r vector. Magnetic field will be in such a direction that it is perpendicular to both your dl vector and r vector. Go through each and every case, and once you feel confident about all these cases, let me know. Every single case you have to do. I can see many of you trying to do it with the left hand. That is why you are getting reverse answers. This is your right hand. Do it. Then we move ahead. Then we move ahead and we move on to magnetic field due to a straight wire. Up till now, we had seen only the formula of magnetic field due to a small current carrying wire, small element. The first formula that comes is magnetic field due to a straight wire. Magnetic field due to a straight wire, and what we have to do is a simple formula. This is a straight wire carrying a current I. You have to find the field at point P. The distance of this point is given as R. And these two angles are given. One angle is given as theta 1 The other angle is given as theta 2. This is case number 1. This is case number 1. The magnetic field due to this wire magnitude is given by mu naught I, and you have to remember this formula, by 4 pi r sine of theta 1 plus sine of theta 2. This is the formula that comes after derivation, which we are not going to do. This is the magnitude of the magnetic field. I will take a pause here and I will ask you to find out the direction of magnetic field. What will be the direction of magnetic field at point P? What will be the direction of magnetic field at point P? Yes. What will be the direction of magnetic field at point P?
Sir, inside?
It will be going inside. So the direction is into the board, which is given by this cross. Do we understand this? Everyone understand this formula? You have to remember this formula. This is the general formula for magnetic field due to a straight wire which makes an angle theta 1 and theta 2 at the point P. Everyone understands this? Okay. Now the next case comes where you will have both the angles equal. So this will be on the perpendicular bisector. Current is I and the distance of this point is R, and now you have both the angles same. Let me call them as theta and theta. Now can anyone tell me what will be the answer in this case? I have already given you the general answer. What will be the answer in this case?
Mu naught I by 4 pi r sine theta.
Take a deep breath and think again and tell me the answer again. Look at the formula again. Take a deep breath and then tell me the answer again. Mu naught I by 4 pi r multiplied by how much?
Oh, sine 2 theta.
Again take a deep breath. Look at the formula and again tell me the answer. 2 sine theta, not sine 2 theta. What is the direction of magnetic field?
Same. Same. Sir, inside.
The direction is inside, and this is the formula that you will have if both the angles are same. You can cancel 2 if you want to, not a problem. That is the formula for a wire which perpendicular bisector of the wire. Let me cut it short. I hope everyone is noting down these formulae.
Yes, sir.
Let me move on to the next case. Now I have an infinite conductor. Infinite means the length of this conductor is very, very large. Infinite conductor. Now, when the conductor becomes infinite, you have to join this point to infinity and you have to join this point to infinity. What happens to these two angles, theta 1 and theta 2? How much theta 1 and theta 2 become if the wire becomes infinite? Theta 1 and theta 2 both will become how much?
90 degrees.
Sine 90 plus sine 90, 1 plus 1. And the answer will be this one, mu naught into 2i divided by 4 pi r. You can cancel 2. So your final answer will become B will be equal to mu naught I by 2 pi r. Do we understand this? Yes or no? No or yes?
Yes, sir.
What will be the direction of magnetic field? That is the next thing that I'm going to ask.
Inwards.
And the direction is still same. It is inwards. I hope everyone is able to understand what I am talking about. Yes or no? One more peculiar case comes here when we have a semi-infinite wire. When I say semi-infinite wire, what do I mean is one end we have, so I can just write semi-infinite length, semi-infinite wire. Semi-infinite means it is infinite in one direction. So it is infinite in this direction. Here we had infinity in both directions. Do we understand this? Here it is infinite only in one direction and the point P is here. So one angle becomes 90 and the other angle becomes 0. Do we understand this? So the answer in this case becomes mu naught I by 4 pi r. Do we understand this? Yes or no? No or yes? I'll give you 2 minutes to note this down. Let me know once you are done. Well, since you have done this, let us move on to the next case. And sometimes you will find a point lie straight ahead, or you can call it a axial position. When the point lies at the axial position, the magnetic field is going to be 0. What do I mean by axial position? What do I mean by axial position? The position like this, that the point lies directly ahead of the wire, or the point lies directly behind the wire. In all these cases, in all these cases, whether the point is directly ahead or the point is directly behind, the magnetic field created by this wire would be 0. Do we understand this? Magnetic field created by this wire would be 0. Everyone has understood this?
Yes, sir.
Okay, I hope you are noting it down. Note it down. Note it down, everyone. Here comes the next question then. We have two wires carrying current, same current, I. The distance between the two wires is D. You have a point P which is exactly at the middle. Point P is exactly at the center of these two wires. You have to tell me the value of magnetic field at point P. I'll give you 2 minutes to think about it and give me the answer. Draw the diagram and tell me what is the answer. Yes, so what is the answer for this one? If I call this wire as the pink wire, in which direction will the pink wire create field at point P?
Sir, inwards.
Inwards. Pink direction, pink wire will create field in the inward direction. What about the green wire? In which direction will the green wire create field?
Outwards, sir.
Are both the fields same or different? The current is same, the distance is same, so both the fields would be same in magnitude, yes or no?
Yes, sir.
So they will cancel each other out, and therefore the net magnetic field will be 0. Do we understand this? Do we understand this?
Oh, yes, sir.
Okay, you can just note down one small point. I think I forgot to mention it here. You can note down the small point which is known as superposition of magnetic field. You can note down this point. You can write superposition of magnetic field. What do you mean by this superposition of magnetic field? If at one point we have more than one magnetic field, the net magnetic field at that point, magnetic field is a vector. The net magnetic field at that point will be addition of B1 plus B2 plus B3 and so on. Do we understand this? So if you have more than one wire creating magnetic field at one point, the net field will be the vector sum of all the fields put together. Do we understand this? Do we understand this?
Yes, sir.
Now, we have applied the same principle here, my dear friends. We have applied the same principle here. These two wires which are there, they are creating the same field, same magnitude, but different in direction. The green wire is creating field outside. The pink wire is creating field inside. Both are same in magnitude but opposite in direction. Therefore, the net magnetic field becomes 0. Do we understand this now?
Yes, sir.
Therefore, the net magnetic field becomes 0. Let me put another question for you. Something I have changed now. The wires are not straight. Remember, they are straight. Let me draw them straight. I keep my So one wire is like this, and the other wire is like this. Both carry the same current, my dear friends, I and I. I have a point exactly at the center, point P. The distance between the two wires is given as D. And the same question is being asked here, bacho. What is the magnetic field now at the point P? Both wires are infinite. Can you give me the answer now? I'll give you 2 minutes. Please try. So how are you going to do this? Anyone got any answer? Anyone got any answer for this one? Now, if I call the left wire as the pink wire, in which direction? Let me call the magnetic field as B1. In which direction it is going to create field? Remember at the point P, which is the midpoint. Yes. It is going to create field in the inside direction. Let me call it as B1. Now let me write the value of B1. How much will be the value of B1? How much is the value of B1? Infinite wires. Formula? Mu naught I by, yes? No one knows it? 2 pi into R, the distance of the point P from the wire. What is the distance of the point P from the wire? It is D by 2. So this gets cancelled, and this is in the cross direction. So the value of B1 becomes mu naught I by pi D in the inward direction. Do we understand this? Yes or no? Okay. Now let us talk about the green field. The current is going downwards. What is the direction of the green field? I hope you can find out the direction of green field will also be inside now. Yes or no? Let me call this green field as B2, and we will see that this green field B2 is also same in magnitude. It is infinite wire, so I have applied the formula mu naught by I by 2 pi. The distance between the two wires is given as D. So distance of point P from the right wire becomes D by 2. This field is also in the cross direction. Now I can find out the net field. The net field will be this field plus this field 2 times mu naught I by pi D, and the direction is inwards. Everyone understands this? How we have done this? Do we understand how we have done this? Everyone understands this? Okay, great. Anyone got the answer of this one? Let me give you one more question. This is the next question. I have this wire carrying a current I, and I have this point P. This angle is 45. This angle is also 45. This distance is given as A. Can you find out the magnetic field at point P? What is the magnetic field at point P? What is the magnitude and what is the direction? I'll give you 2 minutes.
And B is equals to mu naught I by pi r root 2.
Okay. So the first thing is the direction. Current is here. Point P is here. And my fingers are pointing towards my head. That means the direction has to be outside. Yes or no? The
Yes,
only thing
sir.
that remains is the value of B. So remember that formula mu naught I by what is the general formula?
4 pi r.
4 pi r into sine of angle. Sine of 45 is 1 by root 2. Sine of 45 is 1 by root 2. This is the answer. Now we can simplify it. Mu naught I by 4 pi r. 1 by root 2 plus 1 by root 2 becomes 2 by root 2. And the final answer would be mu naught I by 2 root 2 pi. Instead of r, I must write a because in the question it is given as a. That is the answer, my dear friends. Do we understand this? Yes or no? No or yes?
Yes, sir.
So that was the answer. Anyways, I hope you have understood how to do this. Yes or no?
Yes, sir.
I'll give you one question for homework, which I hope that you try at home. And this is the homework question. And the homework question is very simple. I have this. What is this? Huh? What is this? This is a square carrying current I. The length of the square or the side length of the square is A. And we have this point P, which is the center of the square. You have to find out the magnetic field at point P. Can you do that? Yes or no? No or yes?
Yes, sir.
That would be your homework question. I hope you do it and come to the class prepared. Please remember these formulae because these formulae are going to help us a lot. All the question that has ever come based on this formula and one more, which we will discuss in the next class. I hope everyone has understood what we have done in today's class.
Yes, sir. Sir, once can you show the previous question?